Inferences concerning the population regression coefficients, that is, the beta j's. When the model assumptions hold, bj, a specific coefficient in the estimated regression equation, minus beta j, the corresponding coefficient in the true regression equation, divided by sbj, the standard error for the estimate bj as an estimator of beta j. This quotient is distributed with a T statistic with n minus the quantity k plus 1 degrees of freedom. This T statistic is specific to the jth model coefficient, beta j, and when there is more than one independent variable, that is, when k is greater than 1, this T statistic cannot be used to test the overall utility of the model. That's the job of the F statistic. In this section, we develop and practice the two most common applications of this T statistic. The first is to a hypothesis test for the utility of the specific xj independent variable in the context of the multiple linear regression model. That is, in the context of the other independent variables being present in the model. The second application is to obtaining a 101 minus alpha % confidence interval for the true value of beta j, again in the context of the multiple linear regression model. Although we typically discuss these results in the context of beta 1, beta 2 through beta k, that is, in the context of an actual coefficient of an independent variable xj, the results also apply to the intercept beta 0 of the multiple linear regression model, but application to the intercept occurs less often. The hypothesis test for beta j appears in this blue shaded area, which extends to the next page. In this hypothesis test, beta j will be thought of as the coefficient of the independent variable xj in the true multiple linear regression model. The null hypothesis states the true regression coefficient of xj, beta j, is equal to 0. That is, if a value of xj is entered, it will be multiplied by 0 and won't change the estimate of the dependent variable y. Thought of another way, it says the independent variable xj is not useful in the context of this multiple linear regression model. The alternative hypothesis states the coefficient of xj in the true multiple linear regression model, beta j, is different from 0. That is, when differing values of the xj independent variable are entered, the estimated value of the dependent variable y changes. From another perspective, the independent variable xj is useful in the context of the multiple linear regression model. In step 2, we choose alpha, the significance level of the test, and put an upper bound on the probability of incorrectly deciding that the xj independent variable is useful in the model. In step 3, we state the model assumptions, and we've moved to the next page. Assuming the 0 null hypothesized value of beta j, the test statistic is the estimated regression coefficient bj divided by the standard error for bj. This test statistic has a t distribution with n minus the quantity k plus 1 degrees of freedom. Since both large negative and large positive values of the estimated regression coefficient bj favor the conclusion that beta j is different from 0, that is, favor the decision that H1 is correct, the p-value for this test is two-tailed, with half of the probability in the extreme left tail and half of the probability in the extreme right tail. Step 4 involves completing the computations. The Excel coefficients table in multiple linear regression would have k plus 1 rows. The first row for the intercept and the next k for the k independent variables. xj could refer to any one of these rows. As we read down the xj row, the first entry is the estimated regression coefficient bj, and then the standard error for that coefficient bj, and then the quotient of bj divided by sbj, the value of the T statistic, and finally the p-value for the hypothesis test that we've been discussing, this two-tailed p-value. In step 5, we make our decision. We reject the null hypothesis if and only if the p-value is less than or equal to the significance level. If the p-value is less than or equal to the significance level, in this case we are deciding the xj independent variable is useful in the model. The final result for this section is the expression for the 101 minus alpha % confidence interval for the true regression coefficient beta j. This expression is similar to what it was in simple linear regression. The middle of the interval is at the estimated regression coefficient value bj obtained from the coefficients table in the regression output, plus or minus the product of two quantities. The first is obtained from a t-table or from Excel, t alpha over 2 with n minus the quantity k plus 1 degrees of freedom, that's just a single number, times the standard error for the estimate bj, also obtained directly off the coefficients table. We move to the next page. This page primarily provides a reference to the quantities that appear on Excel's regression output. This page provides an application using radio and newspaper advertising expenses to estimate sales of the hypothesis testing method and the confidence interval expression that we have presented. You should work through this example on your own. Remember, it's important that you understand all 5 steps of the hypothesis testing method, and it's important that you're able to create the 5 steps on your own. It's also important that you're able to identify the expression for the 95% confidence interval for a true model coefficient beta j on Excel output. And it's important that you are additionally able to compute, say, a 90% confidence interval for beta j given Excel output. This will end this screencast.